investigation. We're now going to take a look at the Pythagorean theorem, the distance formula, and the equation of a circle. If I'm looking at a right triangle, there's some specific terminology I have to use. The legs are the two sides that meet to form the right angle. The hypotenuse is always the length across from the right angle. So the Pythagorean theorem tells us that the hypotenuse squared equals the sum of the legs squared. When we teach this, I actually use words here instead of letters to help my students better understand that C is a hypotenuse, A and B are legs. So that kind of helps alleviate some of the issues that they're going to have with putting that in proper terminology. So here, if I know that BC is going to be 3 centimeters, and I know that AC is 4, then that's going to be my two legs. So 3 squared plus 4 squared is 25, and I take the square root, and that's where the 5 comes from. Here's a real-life example where I'm going to have to utilize it given the diagonal of the screen. If I'm wanting to find the diagonal of the screen, that's my hypotenuse. So I'm going to plug into the Pythagorean theorem and get 30 inches out. Make sure that you stress with your students to put units on these as you work them if units are given. And this one, I have another example of a pole. And so it's forming two right triangles here from an isosceles triangle. So if I'm trying to locate this, I'm going to apply the Pythagorean theorem to be able to solve for that leg because the 35 is going to be the hypotenuse because it's across from the right angle. And that's where I get 42 feet. Here's another example using a three-dimensional prism where I can also apply some information here. I can first work with finding the actual area, so 1/2 AB, and then I can apply the Pythagorean theorem. I'm sorry, I was not getting the area, we were getting the length. So I can do this. This is a pretty advanced problem. This is not something we're going to typically see in the elementary classroom, but it is possible for certain placement tests that this will pop up. Here are some special right triangles that you want to memorize these facts for. These are going to be highly utilized in most of your 4th, 5th, 6th, 7th grade classes. So the converse of the Pythagorean theorem is working it backwards. So if it's true, then it has to be a right triangle. That's basically what it says. So if I'm trying to determine if these are a right triangle, I'm going to take 85 because it's the biggest side, and 85 squared has to equal 51 squared plus 61 squared. That's true. In B, it's also true. And in C, it's not going to be true because 49 does not equal 9 plus 16. The distance formula is really just an application of the Pythagorean theorem. We often teach it completely separately, but it's not really a separate idea here. So the distance formula is the square root of x2 minus x1 squared plus, the plus is something they frequently forget, y2 minus y1 squared. So when I'm in the coordinate plane, I can use that to find the distance between 2 points. If I want to find the distance between point A and point B, I'm going to take those x and y values and plug them into the root. Now that I have the distance between all 3 points, I see that 2 of them are the same, which is how I know this triangle is isosceles because 2 of the sides have the same measurement. Here, I know that because this is true, it's going to be a right triangle. So if I want to determine whether these points are collinear, I could plot them and very easily see the answer would be no. And I could see they would be vertices of a triangle and not forming a straight line. So here I'm looking at, can I create a triangle from these 3 lengths? And the answer is going to be no, because square root of 10 squared plus square root of 10 squared is not greater than the square root of 40 squared. So we're able to apply that triangle inequality there. So if I'm using the distance formula to develop the equation of a circle, I know the radius would be my x value plus my y value squared, because I'm going to use that right triangle to approximate the hypotenuse, which is also known as the radius. From that, we're able to then get to this standard equation of a circle where we have x minus h squared plus y minus k squared, where h and k are the center of the circle, equals my radius squared. So that's going to be the basics of a circle.